Okay, so let's get started. So it's 5 minutes after 10. So my name is Hamed and it's written here, my email. Okay, so you are welcome to send an email to me anytime that you feel that you've got a question. And so we got 2 times of the like in a week consultation time, and it'll be Mondays and Thursday. So, and the time has written here from 12:30 until 1:30. Okay, and the office room will be advised, but it will be probably SR 241. Okay, so that's the first thing. And in this course, so it's a little bit, you need to work a lot on this course. So in the first week, we will have this sagemath and I will finish it sooner. Okay, that's a good news. And we will do sagemath first week, and then for a few weeks, almost 5 or 6 weeks, we will do ODE, and then we will come back to the sagemath, and so you will use that sagemath because you will need it in the second assignment. You will have lots of coding. You need to do that there. Okay. Okay. So as much as possible. That's fine. Okay. So let's get started with the questions, okay? And whatever, if I remember, I will note it and I will let you know. By the way, I have developed some videos, like the videos that it's related to some you can remember from them from 1120 or 1220 or 10. Okay, and also I've got 2 years ago I have developed few videos about sagemath. If you watch them, you won't have any problems in writing your assignment. Okay, that's the trick that I have used. So, but exactly, you need to like watch it one time, few times, and you just copy the codes and learn it. Okay. However, we are going to do the sagemath today. Okay. Number 1, this is the sagemath website, and it's an open source software, and its compiler is the 3rd generation of the Python. Okay. So here in this worksheet, first week of the lab 1. The worksheet of the lab 1 is this one. Okay, you can find it in the canvas. I just didn't find it, so I just opened this PDF from my local computer. Okay, so I have developed a video about installing sagemath on MacBook, but I referred a video on YouTube, so you can install it on Windows as well. Okay, just to show that this is the website of the sagemath, and you need to, so installation guides are here, and for the download you can, like, let's do Windows here and download complete source code, and you can see that the sagemath has got a server in Australia, so it will be downloaded faster. Okay, for me it was okay to install it on MacBook, and you won't have any problem for that. Definitely for Windows as well. Okay. Now, so also if you cannot install the sagemath online will be another option. In this course, I developed the codes in a way that you won't need to call a previous file for that. Okay, so you can like write everything here and compile it from here. Okay, sagemath sagecell.sagemath.org. Now let's see the questions. In the first week of the ODE, we see that this is the first question. So this is the sagemath. I'm writing it on Jupyter Notebook. Okay. So on sagemath, I just typed this one, sagemath. So this my version is a little bit old. Okay. Once I click on that, it will the Jupyter Notebook will be open on a Chrome browser. Okay. Now we have this code. So sorry, I prepared everything because I don't want to type here. Okay. Let's zoom a little bit. And first question, the differentiation from a function sine x, okay, it can be like this, okay. So you need to define x is variable, okay, unlike maple, okay. In MATLAB, you have to write it sims x, okay. So this little command will do the job and it will differentiate the function in terms of whatever we write here. Okay, right. So 10 of x plus square root of sine x. So the first question. Okay. Shift enter. And the output is as expected. Now, let's do question 2. Okay. Before going to the question 2, so it's possible to define x variable. We can define it f as a function of this 10x plus square root of sine x, and then we can differentiate it f in terms of x. So same answer. And in the other cell, third cell, it's about question 1b. Okay, 4x cubed plus x squared plus 35. Now it's okay. Let's do 1c. So 1c, it's a 2-variable function. The function has been defined on the plane. Okay, so x and y are variables. H is the y sine x. Okay. Differentiation of the h, firstly in terms of y, then after in terms of x. Sure. So differentiation of the h in terms of y, it will be the coefficient of y. So it is sine x. And the differentiation of the second variable, which we have written here, x, it will give us cos x. Okay. So the solve command, I'm talking about question 2, and the solve command will solve the problem. Will give us the roots. Okay. Now here, okay. So This is the command solve. So let's try another one. I'm talking about 2b, okay? X cubed plus 2 times x. So we have this one. So x cubed plus 2x is a polynomial of degree 3. Therefore, the fundamental theorem in algebra tells us that we will have 3 roots or solutions in complex field. So we got some solutions that they are complex, not purely real. So, however, we can restrict ourselves to to some of the solutions, like the real ones. So we have that. So the same polynomial, the algorithm sim pi. So we don't need to be worried about that. Okay. So if you see some sim pi or maxima, they are technical algorithms that the mathematicians developed them, and they put it in sagemath. In fact, sagemath has been developed by the mathematicians. And the domain that we are going to focus is this one, real. So if I compile this, it will give me this, only the real solution. Okay. Right. So if you don't know what a code does, so we can write question mark solve or solve question mark. So it will bring some bunch of information about that command, I hope. Yes. From here, so you can start to search it. So solve the command solve, and if I command F or control F and search the word real, so here the domain, it will teach me how to restrict the real solutions. Of course, it's not that obvious. Let's see the example. So the command and the command solve, it has like arguments. Okay, so solve and arguments and the keywords, and so okay. So as I say, it's not that obvious, but personally, I tried a lot to discover what happens in sagemath. Okay, so the domain and equal to the inside the code, the single quotes real. Okay. Okay. Let's focus on another question. I will talk about question 3. However, as I said in the first, sagemath is compiled, the compiler of the sagemath is the 3rd generation of the Python language, okay? So the engine is Python. All right, so if you stop, or if you don't know what you can do in sagemath, so you wanna like write a loop, or you wanna create a function, just Google that. How can I do this one? Firstly, in sagemath. So the documentation in the sagemath, which is a young language, is not that strong. Therefore, you can Google it. How can I do this task in Python? So 99% it will work in SageMath as well. Okay. You want to, for example, obtain the eigenvalues or eigenvectors. But it's not working. So you can use the methods in Python. Let's focus on question 3. So question 3 teaches us the desolve DE solve command for us. So we see that y prime equal to 2x plus y. Y prime equal to f of xy. We need to write it y prime minus f of xy equal to 0. So everything should be on the left-hand side of the equation. So I should bring these two terms to the left-hand side of the ODE, okay? Therefore, I'm gonna write x is the variable, y is the independent variable to the x, and DE is y prime minus 2x minus y. While it was here 2x plus y, but I brought these two terms to the left-hand side. Therefore, I'm writing here y prime minus 2x minus y. Okay, then these are differential equation solve of this one. So you will need this one in your assignment, and you will be asked that solve this differential equation and plot it. Okay. So let's do this one. Okay. X is a variable, y is a dependent variable, and the differential equation that we want to solve, DE, so which we need to put it here. Okay. And y prime minus 10 of x plus y plus 1. Okay. And so you can also put this one here, this one. So you can ignore one line and you can write everything in one line. So I am talking about this question. Y prime equal to 10 of x plus y minus 1. So in the Sage Math, I'm writing y prime minus 10 of x plus y plus 1, which I have written here. Okay. It's beautiful, isn't it? Okay. All right. So let's talk about differential equation that they got some boundaries or conditions. So we call them BVP or boundary value problem. Okay. So for a few minutes, I'm closing the door, but I'm interested about the main question. So how we are going to write the BVP? So I'm talking about question 3, part C. Okay, I have second order linear homogeneous with constant coefficients of an ODE, and it has these conditions. So one bound is 0 and the other bound is pi on 2. So what we are going to do this one, Okay, so here, y double dash plus 2y prime plus y equals 0. Everything is on the left-hand side. Okay, so x equals 0, y equals 3. X equal pi on 2, then y equal 2. So how I'm gonna write it? X equals 0, y equal 3. X equal pi on 2, and y equal 2. Okay, so here, x, y, x, y, with this order. All right. So shift enter and it gives me the answer. Okay, so now so without the conditions, the answer could be like this one. So it's the second order ODE. Therefore, we have two constants, K1 and K2. Okay. Again, I'm gonna remind you that this year we got some new videos about solving first linear ODE, homogeneous ones, and the non-homogeneous one. Okay. So let's, okay. So question 3D, I'm not writing that one because it's exactly the part C. Let's work a little bit plotting, okay? It's easy. So sin x on x, which is called sinc function as well, with this comment. In Python, you need to call the pyplot module, but in sagemath, you don't have to. In fact, sagemath is a Python which modules have been uploaded in it already. Python, we call it modules, not packages. Packages in other languages such as Julia. So we see that if this is the function sinc x or sin x on x, we know that x, when x is equal 0, the limit is 1. However, if we define it, so f equals sin x on x, and if we try to get the number, it's impossible to get it because for x equals 0, the sagemath cannot distinguish that it should be 1. In fact, the value is not 1, the limit is 1. So sometimes we need to create a function and we put conditions in it. Here is another thing to do that. It's slightly a little bit different than Python, this one. So I plotted sinc function sin x on x, okay, with this comma. So we call them P0. So in another way to write that, P1 plot sine, let's make it a little bit different, 2x on 2x. And the domain that I want this function to be plotted is this one, between -10 and 10. And these are other arguments that you can see the meaning. And such like MATLAB, we can generate the legend as well. So let's try another one, P2. So we can plot this one in a little bit smaller domain. And we ask sagemath to show them together on a Cartesian coordinates, which is gridded. Okay, this one. The first, we have 3 plots. We have 2 legends or labels, and because we didn't ask for the first one any label. Okay, I'm sure that you remember Euler method in differential equation, numerical Euler method for solving equation. So sometimes if you take steps or delta x or h little bit smaller, as bigger, smaller, then your answer will be more precise. Okay. In the assignments, in the second assignment, you will be asked that, okay, solve this question, solve this ODE, then plot it, then solve this ODE using Euler method, okay, with different steps, bigger one and little bit smaller one. Then plot them together. So you need to plot them 3 or 4 plots together, and you will be able to see that, okay, as the steps are smaller, it tends to be close to the plot of the exact solution. That's why we need to learn this one. Okay, so now let's see what we have. In Euler method, you need to, okay, you will learn Euler method, improved Euler method, Hume's method, and Runge type. Please be mindful that the improved Euler method and Hume's method, they are not the same. Okay, please do not mix. So in the Euler method, you have one step. For example, delta x is 0.5, okay? And you need to like get the solution when x is equal 1, okay? So you do one step, so you get the solution in x equal 0.5. Then you go back and do this calculation for another step in order to get the solution or the value of the y when x is equal 1. So you need to repeat this process. That's why you need to learn how to make or create a loop in sagemath. Right. Here. So that's okay, and it is okay, it is easy. So we see that if we want to solve a classic question, which says, let me see which question we are. Okay, we worked on the blocks as well, and okay, so we are working on the if statements, okay, and loop. So 5 and 6 together. All right, 5 and 6 together. Now we see that the first, before starting the summation, everything is 0. So how we are going to write the loop in sagemath or Python? Okay, the structure is the same. It is like this: for I in range of 100. It means I starts from 0 until 99. In Python, unlike MATLAB, it starts from 0. Okay, so range of anything means until that number minus 1. Okay, and this I percentile means I mod 2 equal to 1 means considering if I is odd number, I mod 2 equal 1 means odd number. Okay, if it's odd number, then add it, consider it, and add to the summation. So in fact, we are summing the odd numbers from 1 until 99. Okay. Another way to write or optimize the code is this one. It's possible to ignoring the writing the if condition. Okay. So here we got if condition. Here we don't have if condition. So definitely the results should be the same. So I in range of starting from 1 itself, okay, until 100, and the steps is just like twice, okay, 1, 3, 5, okay, it should be faster. By the way, please note that we don't have end, like we don't end the loop in Python or sagemath. We don't end the if condition, okay, so in fact, the space will talk with us. So if I change the space here, so it shouldn't work. Okay, so it's not like to put if here and if here, so it won't work. Okay. Okay, I brought so I brought this S by just pressing tab. But in MATLAB, this is not a problem. Okay, let's see what we have now. And also for numerical approximation solution, if it's not simplified, it can be done with little n or big N. So square root of the pi is just putting it inside the bracket of n. Okay. And also some other minor things I need to say to you. Okay, I is what's happening to I. In fact, I has defined here, that's why. So in sagemath, the imaginary I is with big I. Right. Now, why do we do the numerical ODE? It is important because sometimes it is impossible to solve. Even the softwares, they cannot. The algorithm in software, they are not viable. So this won't work as well. So the differential equation of y prime minus sine x times y on x plus x. You need to solve it with numerical methods. Okay. Okay, another thing to tell you is another notion in programming languages. So you need a list for writing your codes and for solving numerical ODE. Okay, so when you have a list of the solutions. So the list of the values y. So when in the first step, in another second step, the value of the y. So the second element will be the second element of the list. Okay, so you continue like this. Then at the end, you will be asked to plot your list. Okay, an example of this code has been, it's in the YouTube as well. Okay, so let's do this. Okay, how to create a list like this. List of bracket, lists, parentheses, open and close. How we can append something to that is like this is the same in Python as well. So what happens if we call P? So we have 3 now. What happens? So what happens if we have 8 here? So so 3 and 8. So 3 is already saved in the list of the P. Okay. So okay. Okay, P equal to list. So this is the vector that I define here. Again, so I'm going to call this one. Oh, sorry. So P dot append PTS. So PTS has been defined here, and I'm appending PTS to the list P. So if I call this one, it will bring whatever I have appended already to the list P. So just P or print P will do the job. Okay. Now let's review how we can create a function in MATLAB, in Python. Okay. So in Python, the structure is like this. So again, there is a semicolon, like in loop, if condition, and also it's here in definition of in creating a function. Okay. So it's clear almost that we take two inputs and we add them up together. So after compiling this one, I can write here f of 2 and 3. Okay, and it works. So now let's create an automatic, like this is a list that we can create. We can try to create it like automatically. Here, we define this one, align. So it's not that align. So I don't know what I named this one, align. Another way of creating list is this one. V equal just brackets instead of writing list. For I in the range of the number that n. I starts from 0 until n minus 1. And then append that I to our list V. Right. So I copy this one. 7. It creates the list 0, 1, 2 until n minus 1 or 7 minus 1. but the number of the list should be 7 because it starts from 0. Right. So okay. Now let's see another example. It's possible to list the even numbers. In fact, odd numbers. So I made a mistake here. Okay. So the name should be odd. Okay. Now it's good. Let's see another example. Creating a function. I said that it's same function. It's not working when x equals 0. Okay. So we can write this one by creating condition and imposing a condition of a condition inside definition. We can see that the value of the function in x equals 0 will be 1. So the same function will be continuous. Okay. Let's see some examples about the plots. Then I will try to tell other remarks about the Math2800. Then we will finish the class. Okay. Okay. So I tried f of 0 here. It's possible to try f1 as well, and other values of the same function. Okay. Now let's try this one. Definition of a function which creates different plots for us. Okay. So it is easy to plot the functions together. In MATLAB, you need to use the hold on, but here it's little bit. So it's saying as to write it, show them like, and then if you need to put some arguments, then you need to use the show command. Okay. So the first one should be cos x here. Then after 2 cos x and 3 cosine x. If I need to put the arguments to that, then I should use this command show in order to enable me to put arguments here. Okay. So from the lab, this here, like bit.ly links, they are, you can see the videos that I developed. But it is possible to see E0, 1, 2, 3, 4 until 7 or 8. Okay. So in like episode 4, 5, so I separately explained how to create a function, and in another episode how to create if conditions and loop. And also in last episode 7, probably, or 8, you will be able to see an example which is important to your assignment. Another remark that I would like to share with you is, like, again, try to study this course during the semester. And if you have any question, I'll be delighted to help. And consultation time, I mentioned it earlier. So you can come and see me there. And the other thing, like when you write your assignments, you might have, I think, 2 assignments and final exam. Try to write your assignments very neatly, and I'll consider the working as well. I won't just see the last solutions, okay? Okay, so the class is over, but I'm here still to, if you have any questions.